Okay, so here we're going to be looking at speed, velocity, and acceleration. So when we're talking about speed, we're talking about distance over time. The unit of measurement would be miles per hour, meters per second. So all of those. Right here I give an example, 30 miles per hour. That's giving me an example of distance. Now when we look at velocity, velocity is speed with direction. So it's kind of like me saying going 30 miles per hour north. And then we have acceleration. Acceleration says is a change in speed or direction, or a change in velocity, which could be one or the other, or a change in both. And here my example is a car going towards this direction, and there's a stop sign. So right there, the car needs to slow down before it comes to a stop. So it's changing its speed. Another example that I have right here is that we have a car, and because there's a winding road right here, then the car, even though it's going at the same speed, it is accelerating because it's constantly changing direction in that winding road. So that's speed, velocity, and acceleration. So speed, velocity, and acceleration on page 33. We're not going to work with this practice. We're going to go to the actual problems on the next page. Okay, so we actually went not the next page, but the following one. We don't want to kind of like take time here. We want to go straight to the question. So I'm on page 35 with speed, velocity, and acceleration, and we go to question number 34. So it says, what is the difference between the velocity and the speed of an object? So then right here it says, velocity is the change in the distance over time, while speed is the change in velocity over time. Now remember that velocity was a change in speed and or direction, or a change in both. So that's not it. So then not a change in distance. Now for letter G, velocity has direction. Yes, because we said 30 miles an hour west, or a change in the direction of the speed. So then right here, velocity has direction associated with it, while speed has no specific direction. And yeah, if you remember, over here, we had speed and velocity has with direction. So then right here, it seems like as if that might be the right answer. It says velocity has no direction. Yes, it does. Okay, so then that's not it. Velocity is the change in speed over time. No, velocity is not the change. Velocity is speed with direction. So then let me go ahead and X that out, and it's letter G. Now for number 3, this reminds me of the drawing that I drew on the other page. It says that 3 vehicles shown below are all traveling at the speed of 15 meters per second. But only the pickup truck has a change in velocity. Change in velocity, guys, is changing the speed and or the direction. So then we say that we have an object accelerating. So it's acceleration. Now, they're all going in at 15 meters per second. So then right here, they're going at the same speed, but these are going straight. This one right here changed direction. So right here, this is the one that is accelerating. So then let's go ahead and look over here. The pickup truck has a change in velocity because the pickup truck has a change in velocity because, let's see, A can accelerate faster than the other 2 vehicles. No, they're all 3 going at 15 meters per second, meters per second. So then, nope. The pickup truck is traveling in the opposite direction from the other 2. Nope, they're all going in the same direction. C, the pickup truck is traveling on a curve in the road. You know what? I like this one. There we go. Accelerating because of that. The pickup needs a large amount of force to move. Nope. So then it might need more force, but that's not reason that it's changing velocity. So the correct answer is going to be letter C. So let's go ahead and look at the next one. Number 37. Which of the following best describes the velocity of an object? Remember, velocity means speed with direction. So we need the speed and we need the direction. 30 miles per second. It's giving me speed. There's no direction. 30 meters east is telling me distance and direction. No, I don't want distance. I want speed. 30 meters per second. I like that. This is the speed. And this is east, the direction. Okay. That one. 30 meters per second square. No, this one is actually giving me acceleration. So the correct answer is going to be letter C. Let's go to the next one. Okay, so we're on page 36, still with speed, velocity, and acceleration. So then we have the next question, question number 22. It says, a meteor moving 468 kilometers per minute, traveling in a south to north direction, passes near Earth in 2013. Because the meteor was only 45 meters wide and was 27,700 kilometers above Earth's surface, it was not visible without the aid of a telescope. Which statement describes the meteor's motion? So then right here, okay, so it just wants to know how the motion of the meteor is. So its velocity was 7.8 kilometers per second northward. Or its acceleration was 468 kilometers per second square. Well, right here it's 468 kilometers, but not per second. So then I'm going to say this one automatically is out. This one, I know that it's talking about south to north. It's giving us the direction, and velocity is speed with direction. Okay? Its speed was 468 kilometers per second northward. But it's not northward. It's south to north. So no, that's not it. It's south to north. Its acceleration was 7.8 kilometers per second. No. Okay. So then right here, no matter what we do, and if you say, you know what, maybe they want me to get its acceleration, but for acceleration, we need the force, we need the mass. So then right here, there's really no force. It's giving me distance. So based on the information that I have, I am going to say that the correct answer will be letter F, based on the best possible information. So then letter F. Let's go ahead and go to number 10. It says, a student investigates the motion of a toy vehicle. The student grabs 40 seconds of data from the investigation. So 40 seconds up to right here. That's my data. Which statement best describes the motion of the toy? So I need the motion of the toy vehicle during the first 30 seconds of the investigation. So it only wants the first 30 seconds. So this is up to 40. So I'm going to go straight the first 30 seconds. This is the motion. So I'm going to be looking for 30 seconds. And this is what, like 10.5? I mean, not 10.5. I'm sorry. This is going to be like a what? 10, 11, or 12 right here. Oh, okay. Now, motion, it's looking at the motion, so they don't want to know the actual speed. They just want to know whether it's constant or whether it's increasing, whether it's accelerating. So, because this is distance, guys, we're going to say that this is position. So then that means that the object is moving away from home. So this would be kind of like Miss Colby going to Walmart. So I'm 1 meter away from home, and I would put right here, I would say, okay, this is 5 meters away from home, 10 meters away from home, 15 meters or 13 meters away from home. So then when we see a line that goes straight, then we say that right here it's going at a constant speed. Constant. Now, if this was speed, I would say I'm speeding up. But I'm not speeding up. This is constant for distance. For speed, this would be increasing my speed. But here I'm not increasing, I'm keeping the same speed. So then it says the vehicle was traveling at a constant speed. I think so. The vehicle was accelerating. No. For acceleration, it would kind of like curve up. It would kind of like show, okay, all of a sudden I'm going to increase my speed. The speed of the vehicle was increasing. No, that's the same as accelerating. The acceleration of the vehicle was increasing. It's not increasing. It's staying the same. So my correct answer is going to be letter F. Thank you, guys.